So in this video, I'm going to take you through something that's referred to as expanding binomials. And all that means is you are going to take a binomial, a two-term polynomial, and you're going to raise it to a power, such as power 3, or a binomial to power 2, and so on. As you get to higher powers, it would take you a long time to multiply x plus y times itself 5 times. And so the alternative is to do something called binomial expansion. In order to do this, you need to be able to see a pattern with these numbers in red, the leading coefficients, and you also need to be able to see another pattern that is just in the letters themselves. So we'll just take a look right here. For x plus y to the second power, if you notice the x term is going x squared, the next middle term has x to the first, and the last one doesn't have an x at all, which would be x to the 0 power. And in the opposite direction, that y value is going y to the second, y to the first, and no y's. It works the same way through all of these. So if you look down at the fourth power, it goes x to the fourth, x cubed, x squared, x to the first, and no x's. And the y's do the same exact thing in the opposite direction. The next part, the red numbers, the leading coefficients, that's coming from something called Pascal's triangle. And this is Pascal's triangle. If you notice, the red numbers are the same, 1, 1, 1, 1, 2, 1, and so on. And how this works is, what's really happening is 1 plus 1 gives you 2. And now your outside numbers are always 1, and then to find the other numbers, you're just adding 2 consecutive numbers. So 1 and 2 make 3, and 2 and 1 make 3. And then again, you have 1 on the outside, 1 and 3 make 4, 3 and 3 is 6, and 3 and 1 is 4. Okay, so this Pascal's triangle, it is something that a guy named Pascal actually came up with, and it's useful for, among other things, binomial expansion. Okay, so what we're going to do, I'm going to show you how to do a problem. This is how we looked at it in class. I have this binomial to the fourth power. So because it's the fourth power, what I'm going to do is I'm going to use these numbers here because they indicate, because of the 4, a fourth power. Okay, so I'm going to go ahead and write those down. 1, 4, 6, 4, 1. Alright, now back up here, I had x plus 2, so that means that each term is going to have an x and a 2. Okay, and then just like in our other problems, what's going to happen is the x is going to go from starting with this degree, 4, and it's going to count down all the way to 0. And then the 2 is going to work in the opposite direction. So it's going to go 4, 3, 2, 1, and 0, which means it's not really there. Okay, and the 2 will have a degree of 4, 3, 2, 1, and 0. Okay, which means 2 to 0 is really 1, it's not really even there. So, then to find out what we have, okay, what this is actually equal to, we actually need to multiply each thing. So that's 1 times x to the fourth, which is x to the fourth power. This second row, okay, we have 4 times x cubed times 2 to the first, which is 8x cubed. Alright, the next row is 6 times 2 squared and x squared, which is 24x squared. Alright, the next row, 2 to the third power times 4, which is 32, and that's x to the first. And the last row is 1 times 2 to the fourth power, which is 16. Okay, so your final answer is, let's see, I'll change colors for you. That multiplies out to x to the fourth plus 8x cubed plus 24x squared plus 32x, okay, plus 16. And that is your final answer. Okay, that's actually what x plus 2 to the 4th power is equal to. It multiplies out to all that. Okay, so I'm going to look at one more example with you. A plus 5b to the 3rd power. So again, we have a binomial to the 3rd power. Okay, so we're going to use this row here because of the 3rd power. Okay, so I'm going to start off with that. I need a 1, a 3, a 3, and a 1. And then I need to put a and 5b all the way down. Alright, so I've got my a's written down, my 5b's written down. And again, this thing is going to use, okay, the a's is going to go 3, 2, 1, 0, while the 5b will do the same thing just in the opposite direction. So it's going to have 3, 2, 1, 0, and 3, 2, 1, 0. Okay. So from there, all you really have to do is multiply everything together to figure out your separate terms. In the first row, 1 times a to the 3rd is a to the 3rd power. The second row, that's a 3 times a squared times 5b to the 1st, which is 15a squared and b to the 1st. The second row, that's a 3 times a times 5b squared, which 5 squared is 25 times 3 is 75, a b squared. And lastly, that's 1 times 5b to the 3rd, which is 125b to the 3rd. Okay, so this is, once I add these all together, okay, this is my final answer. So this right here